In this demo application here, where you can add different tasks, and I know to-do lists or task lists like this are pretty much a cliche at this point when it comes to uh, web development tutorials, but it does kind of get the point across well. So we have this task list, and you can add new tasks, you can delete them, edit them, save them, mark them as checked, so on and so forth. Now, we currently manage this with just using React state. So if we go to the actual component here, what you're going to see is that we have this use state to where we manage our list of tasks. And then we have our like edit task ID, edit task title, new task, so on and so forth. And then throughout this, we have a function to add a task, delete a task, toggle the completion of a task, start editing a task, save editing, and then kind of all of our JSX here to render things out and to call the different event handlers. So that's great and all, but today we're going to kind of convert this to, instead of using just the use state hook in React, we're going to use the useReducer hook and use reducers to manage this state rather than just using use state. Now, towards the end of this video, we're going to cover some like pros and cons of reducers because, you know, they're definitely not the go-to solution for managing state all the time. And, you know, we'll kind of see what it looks like here, as sometimes it actually results in more code, but it can also be more manageable. So there's kind of a little bit of a give and take with reducers, but I'm going to show you how the useReducer hook works and how we could kind of fit it in to this task manager component. So first of all, I probably don't need this side menu open, and we can kind of clear up those files up top. But what we're going to do first here is we are going to skeleton out our useReducer call. So instead of having our use state call here, what we're going to say is, and this is going to, of course, throw errors here at first because we're going to have duplicate pieces state, but we're going to say const tasks, comma, dispatch is equal to useReducer. So this is a hook from React, very similar to use state. It's just another hook that helps you manage state. But what it's going to accept as arguments here is, first, it's going to be a reducer function. So in our case, we're going to call it task reducer. And what a reducer function does is it effectively takes multiple things and then reduces it down to one thing. So in our case, it's going to take the current state as well as some sort of action that the user takes, and we're going to display that or represent that action as just an object. So it's going to take the current state and an object, and it's going to reduce that down into what the new state should be. And I'll, of course, create this function and show you more of how it works. But then as a second argument to the reducer function, it is going to take the initial state. So what we can do here is above our task manager component, and if you see this use client here, just ignore it. This is technically a Next.js project, but this is all just pure React code. What we're going to do here above our component is I'm going to say const initial state is equal to, and it's basically going to be what our initial state was right here for use state. And I'm going to pass it like so. And I'm just going to get rid of this use state call here. Now the useReducer hook, it's going to return our current state, and it's also going to return a dispatch function. And all this is a way for us to tell our reducer function effectively what action the user took. So when we call the dispatch function, we might say something like, the user added a task. Okay. And then the reducer function is going to accept the current state and that action, and then just figure out how to update the state from there. So let's actually start building out this reducer function. So below my initial state here, I'm going to say const task reducer is equal to, well, what arguments is it going to accept? It's going to accept the current state, and I'm just going to say it's state. And it's also going to accept some sort of user action. So action. And then we're going to make this an arrow function. And now once in this function, what we basically need to do is, okay, we need to see if the action was that they added a task, then we need to update the state based on that action. If the action was they deleted a task, we need to update the state based on that action. So a very common way to do this is using a switch statement, because we're going to have different cases of different actions the user took. Now you can also write this using if statements, and that sometimes that can be the better approach. But for me, I tend to like using the switch statement because, as you'll see, you can kind of more easily see the different cases for that switch statement. So we're going to say switch, and then this is going to be on the action, and we're going to pass a type property on the action. So action.type, what type of action is it? And this is kind of the convention when using reducer functions. And we'll open up curly brackets, and then I'll do case. And then what should our first case be? What should be an action that we handle here? Well, we should handle whether the user added a task. And one kind of small note is that I am kind of thinking in more so past tense here. So like added a task rather than add task. I've seen it either way, but for me, it just kind of makes more sense like handling an action that the user took. So added a task, deleted a task. So kind of making things past tense to me makes a little bit more sense. And I would say probably is what you're going to see a little bit more often. So for our case, we want to do added a task. And in our dispatch function, we are going to dispatch an object to where the type is added task. So to prevent us from repeating ourselves here, what we're going to do is we're going to create a constant, and I don't know, maybe I'll just say const task reducer, and that's going to be an object where added task is going to be added task. And then I'm going to also do deleted task, toggled task, and edited task. So we have our constants set up here. So now the first case is going to be, we'll do task reducer dot added task. So what do we want to do if they added a task? Well, we're going to return an array where we're going to spread in the previous state. Then we're going to add a new piece of state where the ID, we'll just be a little hacky with it and just do date.now. But you're probably going to want to use like some sort of, helper function to generate a ID. The title is going to be, well, on our action object, we also want to pass basically the title of the new task. And the convention here is to pass it on the payload. So for this, the title is going to be our action.payload. So when we dispatch this action, we're going to want to make sure that for an added task, we want to, on the action.payload, pass the new name of the task. And then completed is going to be false for an added task. And really, that should be it for adding a task. But now we just need to go through the other cases here. So another case is going to be task reducer dot deleted task. And then in this case, we need to return our state dot filter. We're going to accept a task. And we're going to say the task dot ID is not equal to the action dot payload. So when we dispatch an action for a deleted task, the payload should include the ID of the task that we want to delete. And then here we just filter that out. And real quick, whatever you return from the reducer, that is going to be your new state. So we're returning for our added task, our new state plus this task here. For the case of a deleted task, our new state is going to be filtering out the action.payload task, the one we want to delete from our current tasks. So whatever you return from your task reducer is going to end up being your current state. Now we need to do our toggle task, or we're going to return our state dot map, accept our task, and then say task dot ID is equal to action.payload. If that's true, then spread that task, but say completed is going to be equal to task dot completed, but we need to make sure to toggle it. So we'll say not task dot completed, else just return the task. So map over our tasks, find the one that matches our action.payload, toggle the completed, else just return the task in our map function. And then the final case here is going to be our task reducer dot edited task, or we're going to return state.map task, find the task.id is equal to the action.payload. If that's true, spread the task, but then set the title to be the action.payload. Title actually is what we're going to want to do. And this should be action.payload.id, else just have it be the task. So in this case, our payload for an edited task is actually going to be an object that is going to have our action.type on it, but it's also going to have an action.payload, which is also an object that has an ID of the task that we want to edit or that the user edited. And then also the payload is going to have a title, which should be the new title for the edited task. And I will fix these case statements here as well. So let's make sure that they're all kind of lined up with each other and a little easier to read. I would definitely recommend using Prettier, but I do not have that set up right now. But by default in our case statement, we will actually throw a new error and just say unknown action type. And you might also like console log or log out the action or the state right now as well. But we'll just kind of throw this generic error. So that kind of sets up our task reducer, which we're already passing into our task manager here. And then really from here, all we need to do is update our functions to dispatch actions instead of like manually updating the state. So for add task here, we'll keep our check. If the new task is empty, just don't do anything. And we'll also keep our set new task title, kind of resetting the state here. But for kind of this in between here, all we need to do is call our dispatch function with an object to where the type is task reducer dot added task. And then the payload, that should be our new task title. So that kind of, to some degree, simplifies our add task function, and kind of a lot of the logic for managing our state is now just in this one single reducer. Since I used a switch statement, you can easily see the different cases here. If you're like debugging, okay, deleted task isn't working, it's very easy to come and find deleted task here. So that should be add task. For delete task, instead of this logic kind of directly here, we're again just going to dispatch, call that function with an object to where the type is going to be our task reducer dot deleted task. And I definitely could have named that constants object a little bit better. But then the payload is just going to be the ID that we pass into deleted task. For our toggle task completion, instead of setting the state directly, we are also just going to dispatch an action object that has type task reducer dot toggle task. The payload is going to be the ID once again. For start editing, that's going to remain the same because we're still using set state. So you definitely can use useReducer with use state calls, that's perfectly fine to do. But then the save edit is going to be a little bit different, where instead of setting tasks directly, we're going to dispatch our action to where the type is going to be task reducer dot edited task. And then this one, our payload's a little bit more complex. So we'll have a payload that is going to be an object to where the ID is going to be our edited task ID or our edit task ID. And then the title is going to be our edit task title. And then everything within our code should remain the same because we're still calling all these functions with the same stuff. We might have actually wrote a little more code there with adding the reducer and adding these constants, but some would argue that this is a little bit more easy to manage because we're just dispatching actions here from these functions rather than immediately updating the state. So a lot of our state logic is just in this one single function that might be a little bit easier to maintain and debug if things aren't working quite correctly. And this is Editor Ryan here, but just as a quick note. So I'm not sure if this was clear going through the video and editing it, but when you call the task reducer, your reducer function with dispatch here, so like we dispatch this action, you see that we're not calling it with the current state. And that is because React will automatically pass in the current state to your reducer. So when you dispatch an object or an action, that is effectively immediately passed into the second argument to your reducer function because React will already pass the current state to your reducer. So if that kind of seemed a little bit magic in the video, just know that React automatically passes the current state to it, and then your dispatch function effectively calls your reducer. But since React is already going to pass the current state into it, your action is just going to take that second argument there. So if that was confusing, hopefully that clears it up. So let's go see if this works here. Let's refresh to make sure we're all good. I'm going to add another task, another one here. Let's see if I can toggle them. It looks like I can. Let's edit this one. Let's save. That looks good. Let's delete. So it looks like everything is still working correctly. All we changed was how we manage state under the hood, which is exactly what we want. Let's head to the React docs and just finish on a few things that are important to note. So in their docs here, I'm going to just run through some of their comparison between useState and useReducer, just to kind of give you another overview and kind of their perspective on it. So for code size, generally with useState, like I kind of showed you, sometimes you have to write less code up front, but with useReducer, you have to write both a reducer function and dispatch actions. However, useReducer can help cut down on the code if many event handlers modify state in a similar way. So yeah, it does depend. It is kind of a case-by-case basis, but I would argue that it's not bad to write more code sometimes if it makes things a little cleaner and more manageable, which I think useReducer sometimes does do, but I also think sometimes useReducer does just kind of make things a little bit more complex than it needs to be. Readability, useState is easy to read when the state updates are simple, but when they get more complex, they can bloat your components code and be difficult to scan. In this case, useReducer lets you separate the how of the update logic from the what happened of event handlers. So rather than in our kind of event handler functions right here, rather than focusing on updating the task state directly, we just had to dispatch an action saying, okay, what happened? They added a task, they deleted a task, they toggled a task, and then we let our reducer manage how to actually update that state. So it's kind of separating those concerns there is what they're getting at. And then with debugging, when you have useState, it can be difficult to tell where state was set, but with useReducer, basically everything happens within a reducer. So when we were using useState earlier, we were setting the state here, we were setting the state here, we were setting the state here. Sometimes you'll see it also be done in the event handlers themselves, and we're setting state in all these different places. With useReducer, We're really just setting state in our reducer function. And then for testing, a reducer is a pure function that doesn't depend on your component. This means you can export and test it separately in isolation. While generally it's best to test components in a more realistic environment for complex state update logic, it can be useful to assert that your reducer returns a particular state for a particular initial state and action. So could have some testing benefits. I'm kind of on the fence about this one. I think that you can still find ways to test your components regardless of whether it's using a reducer or use state. Personal preference, some like it, some don't. That is definitely for sure. For me personally, I'm kind of meh. I tend to default to using use state, but sometimes if it is like a more complex piece of state that is being updated in a bunch of different event handlers, sometimes it is helpful to kind of separate things out into a reducer. But for the most part, use state is my default until things start getting a little bit unmanageable. Then I'll switch over to use reducer. And then for a couple of things for writing reducers well, just make sure your reducer function is pure. And then also each action describes a single user interaction, even if that leads to multiple changes in the data. For example, if a user presses reset on a form with 5 fields managed by a reducer, it makes more sense to dispatch one reset form action rather than 5 separate set field actions. And then I'll of course link these docs in the description below if you want to read more about this. But let's do one last overview of the code here of what's going on, just to make sure that we're all on the same page. So the useReducer hook in React, it's going to accept a reducer function as the first argument. This reducer function is simply going to be a JavaScript function that takes 2 arguments, the current state, as well as an action object that represents some sort of user action that the user takes. From there, within your reducer function, you're going to see what action type it is, what action the user took, and then you're going to return some new state based on the current state and whatever action it was. And in that action, you might also send a payload if you need more information on how to update that state. And that payload might contain the title of a task, the ID of a task, or different things to help you update the state based on whatever action it is. And then whatever you return from your reducer function, that is going to be your new updated piece of state. And then as the second argument to useReducer, it is just your initial state. useReducer is going to return an array of 2 items. The first is going to be your current state, just like the useState hook. But the second is going to be a dispatch function that allows you to dispatch actions for your reducer function. So then throughout your code, instead of just calling the set state function directly, you actually just dispatch using your dispatch function an object that contains basically the information needed for you to update the state in your reducer function. So in add task, we dispatch an object that has a type saying the user added a task, and then the payload of the new task. Same thing with delete task, dispatch an object to where the type is deleted task. The payload is the ID of the task we want to delete. Same thing for toggling a task as well as editing a task. But this time our payload is actually an object with a little bit more information, the title and the ID. So really not too complex. I think sometimes people are a little scared of reducers, but you're really just probably a step more complex than using the useState hook. So hopefully this video kind of helped you see some of the pros and cons of reducers, where they might be useful, and how reducers work in React. So thanks for tuning into this, and I'll see you in that next one.